It won't be heard anyway. So, no, Avery, you cannot make snarky comments.
That'll be heard.
Yes, that will be. So, here with this example, we're using something that would be found in a table, but it's not found in the table in our book. So we've just given the formula here, and we see that we need to do a substitution. We've got this e to the u here. So, right, so u equals negative x squared, which means we have du equals, and don't forget dx.
But we want to change that negative 1/2.
Right, we don't want the 2 there, so it's going to be negative 1/2 du is x dx. Okay. So what are, let's see, any other values that we need here? No, it looks like everything else is covered. So we just start plugging into the formula. So u, which is negative x squared, that's an equal sign there, minus the natural log of 1 plus e to the negative x squared plus c, and there's one other thing that we need there, and that is the negative 1/2, because that went with the du. So probably would have been a good idea to rewrite from the beginning that we had negative 1/2 the integral du over 1 plus e to the u du. So had we written that first, it would have helped us to remember that negative 1/2 out in front.
That's the cursive expression.
Okay, formulas 82 to 85 in our book. So in the back, find formulas 82 to 85. Actually, it looks like just 84 through 86. And then some other ones later on. Notice that the answer has an integral in it. So that means these are what are called a reduction formula, because we're going to hopefully make that a simpler integral than the original one that we can then find some other way. So we have x cubed sine x here. Looking at the formulas 84 and 85 there, well, it's a sine, so it fits the form for 84. Let's write a couple things down. And we see that following formula 84, the n value is 3. What's u? U is just x, so we don't have to worry about that part. Okay. So n is 3. So this integral, according to the table then, is negative x to the third sine of x. Yep, cosine of x, I jumped to the wrong formula. Don't let your eyes wander to the wrong formula. Cosine of x, 3. Okay, so x squared. Which we didn't need to because x and u were the same thing. So dx. Okay. Well, we have a slight problem. Exactly right. We're going to go to formula 85 now and apply that to the integral that remains there. Ah. So Noah is suggesting that this could be done with integration by parts and the tabular method. Yeah. Ah. Okay. Try that. I think it would. I don't see any reason why not. Which, is it easier to use the tables or the tabular formula? Probably the tabular in this case. Now, if we had some other things here where u wasn't just plain old x, then maybe this formula would help out more. So let's go through it and follow this technique to finish it up. But yes, if it was just this original problem, I think the tabular method's going to work better. Yes. Okay. So using formula 85 then, we have, well, this first part's going to stay the same. We have negative x cubed cosine x plus 3 times. Okay, so for this one now our n value is 2, and our x again is just, or our u is just x. So x squared sine of x, this is according to formula number 85, right? Minus x yeah, we're kind of hoping that, yes. And usually. Okay, let's go ahead and distribute the 3 there to make that a little nicer. So we have negative x cubed cosine x plus 3 x squared sine x minus 6 integral x sine x dx. Okay, so now what do we do with that? Now it's formula 82, the integral that's left. Okay, so we have negative x cubed cosine x plus 3x squared sine x minus 6 times. Okay, so this time formula 82 tells us that we have just x cosine x. And of course we would go ahead and distribute the 6 there to finish it up. So next we want to use the tables for this definite integral. And of course, if we substitute a u value, we'll want to make sure that we change those limits of integration. Now we do have a hint on this one. And so why don't we start off with the hint? Maybe it's going to give us the number of the table that we want in the table or something. And see what we... Oh, that's not quite the hint we were looking for. Okay, well... Izzy, good to have you with us now. And so we're going to look in our tables and try to find something that fits this form. So we've looked through the tables. We haven't really found what we wanted for this. But if we think about basic algebra, can we take this and rewrite the integrand a different way? Well, the integrand is a division, right? So can we take that and divide? X squared plus 0x plus 4, and we want to see how many times that goes into. X squared plus 0x plus 12. A little long division. Long division in integrals is not that uncommon. So if we take that, let's see, x squared into x squared, so that would be just a 1. And we have x squared plus 0x plus 4. And we change the signs and add, and we end up with 8. So what do we really end up with as an answer here? It's 1 plus, now we don't want a remainder, 1 plus
X squared plus 12 over 8. Or 8 over
8
that.
over x squared plus 4.
Ah, okay. So let's rewrite our integral then using that. Glad to see Izzy is watching on here. Okay. So we have the integral then from 0 to 2 of 1. Now, since this is an addition, can I split the integral up into two parts? 1 dx plus the integral from 0 to 2, 8 over x squared plus 4. Well, dx. Could I do one little change there? Do you see a little change I might want to make on that? It involves that. Let's move the 8 out in front of the integral. Now let's look at our tables again and see if we can find something. We know the left side of this we can do easily. But look in the table for something relating to the right side. So that we see that number 17 fits very nicely here. And our u is just going to be x. We don't have to worry about the du dx thing. And our a value is 2. So if we take this and anti-differentiate now, yes? Right. And is that any different than what we have here? Because this dx we can write here instead of putting a 1. And this is addition, so we can change the order. Okay, so antiderivative of 1, well, that would just be x plus 8 times, and now we look at our formula. From number 17, we have 1 over a, so 1/2. Inverse tangent, okay. U over x over 2. And we're not going to do a plus c because we're doing a definite integral. Did we do a substitution that we need to change the limits of integration?
Well, it's the same.
Right. We didn't do that. We don't change the limits of integration, so we would just evaluate that from 0 to 2.